The electric power industry Scada system has been designed for laboratory and practical study of supervisory control and data acquisition in the power production and distribution field. The student may use the lab software along with the command console for the design of power networks and practical study of their architecture, create a mathematical model of the power distribution system, and calculate the main operational parameters of the power station. The test bench can also be used for design of power network SCADA system, implementing the monitoring and control of its main parameters. The bench provides simulation of hydroelectric plant, simulation of nuclear power plant, simulation of wind farm, simulation of solar power plant. The software has simple and intuitive user interface. You can see start window of the program with following elements. New project for creating new projects. Open the project for opening the editing previously created projects. Close for exit from the system. Now we're going to create new project by clicking on the new project button. This is the main window of the program. This window consists of following areas: Tools menu, Advanced Setup menu, Error Detection fields, Workspace. Tools menu consists of stations, which include all the power generating plants such as hydropower plant, wind farm, nuclear power plant, solar power plant, and consumer. Controller for processing data from the plants. Database, network tools, user interface. Also there are elements advanced setup menu. Start button, button for checking an IP connection between network components. Let's try to build new SCADA system using Workspace. SCADA system has to be collected from the available elements of the Tools menu. Each component should be moved to the corresponding field of the block diagram. After, we should set IP configurations of each element of the block diagram. Then we must check the connection between all components by clicking corresponding button, and you can see all indicators are green. It means that the network configurations are done correctly. Next, after all manipulations, we go to the operator window. In this window, system is presented in the form of topology. This interface allows you to construct power grids by configure power lines and transformers. And also you can monitor main parameters of each station such as active, reactive power, frequency, voltage. There are also fields of generated active, reactive power, electrical grid, frequency, generated power of each plant expressed in percentage. Next, we are opening hydropower plant window. This interface is a mnemonic scheme that displays model of hydropower plant with control and display elements through which we can manage control of power generation processes. Hydro plant window consists of reservoir, generator, transformer, three-phase electric grid, indicators. Main control element for power generation is water flow rate. By rising water flow, generators start to work, and after rising voltage, generator will connect to the electrical grid. Then you can see that generator is successfully connected to the grid. You can also change water level reservoir, water inlet, outlet, time of filling, emptying the reservoir, and operating pressure using the corresponding control elements. Now we're opening consumer window. Consumer window indicates consumed power level by indicators of each consumer category. There are 3 categories of consumer located by increasing priority: medical facility, manufacturing, enterprises, and residential areas. Priority of consumer is important to provide electricity rationally. Here is also field of active and reactive power, which indicate generated and consumed power. Also, we can control plant's voltage and frequency. Now we open other plants interfaces for fluently familiarization. Nuclear power plant, wind farm, solar power plant.